Welcome to this BigQuery tutorial on selecting columns. We'll be exploring select asterisk, except, replace, distinct, and all. To get started, you'll need the CSV file we'll be working with and a BigQuery Sandbox. I've put links to both of those in the description below, so go ahead and grab those. Once you have those, create a new dataset in BigQuery, and then create a new table from the CSV file you downloaded. If you're new to BigQuery and need help with these initial steps, just leave a comment and I'll create a video specifically on setting up your environment and importing data. Okay, we've successfully imported our CSV file into BigQuery. Let's preview the data to get familiar with it. Here's a view of our imported table. Now the goal is to recreate this view using SQL. We'll begin with the select statement, followed by the asterisk. The asterisk or star asterisk after select is a shorthand way of saying select all columns. So select asterisk means give me all the data from all the columns in this table. Then specify the dataset name, followed by a period, and finally the table name. A really handy feature in BigQuery is the query validator. If you highlight your query, you'll see an estimate of the data that will be processed. This helps you understand the cost implications of your queries. And if there are any syntax errors in your SQL, this green check will turn red, providing you with a clear explanation of the issue. The error icon will give you even more detailed information. Now, if we want to select specific columns instead of all of them, we can replace the asterisk with the names of the columns we want. The fewer columns you select, the less expensive your query will be. It's good practice to only select the data you actually need. The from clause isn't always required. We only use it when we want to select data from a table. For example, we can run a query like this. Because the number 3 doesn't have a column name, BigQuery assigns a column name according to its rules for implicit aliases. This is what we call an anonymous column. We can give this column an alias, so it's no longer anonymous. We do this using the as keyword. After running this query, you'll see the alias used as the column name. Now going back to our flowers table, we can do the same thing with columns that already have names. For example, to create a new column that's double the number of petals, we can add a comma in an alias for every column we want to select. The as keyword is optional. So this query is equivalent to this one. If you don't provide an alias for an expression, the column is anonymous. And if a column is anonymous, you can't refer to it by name anywhere else in the query. Let me show you an example. When I create this query, I don't know what the column name of the first column will be. And guess what? BigQuery doesn't know either until the query is executed. That's why it's called anonymous. Once I run the query, I see that the generated name is F0 underscore. So if we try to order the results of this query, BigQuery doesn't know what F0 underscore refers to because we didn't provide an alias for the first selected expression. It's an anonymous column. But if we provide an alias like this, BigQuery now understands that more underscore petals refers to the first calculated column. Now, if you're not familiar with the order by clause yet, don't worry. We'll cover it in detail in a future video. But as a quick bonus, you can also use column numbers in the order by clause to refer to columns by their position in the select list. For example, order by 1 refers to the first column, order by 2 refers to the second, and so on. We'll dive deeper into the order by clause later, So make sure you subscribe so you don't miss that lesson. Now, what if you have a table with 500 columns and you want to select all of them except one or two? Typing out all 498 column names would be a nightmare. Luckily, BigQuery provides the except clause for exactly this situation. This selects all columns except flower name. Much easier, right? However, anonymous columns cannot be used with the except clause. If you try to use an anonymous column in except, you'll get an error. For example, this query will result in an error because F0 underscore is an anonymous column generated by the subquery. BigQuery doesn't know what F0 underscore refers to outside the context of that immediate subquery's output. The issue can be resolved by adding an alias. Selecting data from structs, JSON, and similar data types is a more advanced topic, so I'll dedicate separate in-depth videos to each of those. Before we dive into the replace statement, let me show you how to concatenate two strings. If you're not familiar with the term concatenate, just think of it as joining strings together. You can join two strings in BigQuery using the double pipe operator, vertical bar, like this. This will return a single string, string 1. String concatenation is an expression in SQL. Just as 3 multiplied by 2 is an expression, you can create expressions using column names. For instance, you can multiply a column by a number, like column underscore name asterisk 2, or use other operators and functions. And you can do it for as many columns as you need. This creates a new column named name underscore with underscore prefix by adding underscore underscore to the beginning of each flower name. Now, if you want to select all columns, select asterisk, but apply this type of transformation to just one column, you can use the replace clause within select asterisk. Let's get back to the replace statement. This query selects all columns, but importantly, it replaces the original petals column with the result of the expression petals asterisk 2. It doesn't change the order of the columns or add a new column. It modifies the existing petals column. This is similar to the previous query, but it directly modifies the selected columns. You can apply this to multiple columns by separating the replace clauses with commas. Now, if you want to remove duplicate rows from your results, you can use distinct. A select distinct statement discards any duplicate rows and returns only the unique rows. When you select distinct across multiple columns, duplicate means that the combination of all selected columns is identical in multiple rows. So if we select both flower underscore name and color, this will return only the rows with unique combinations of flower name and color. By default, select returns all rows, including duplicates. You can explicitly use the all keyword, but it's redundant because it's the default behavior. In BigQuery, you can use backticks to create aliases that contain spaces, giving you more flexibility in naming your columns. I've added a link in the video description about flexible column names so you can check which characters are not supported. If you want to see a video about this, leave a comment. That's it for today. I hope you found this helpful. If you enjoyed this video and want to see more like it, don't forget to hit that subscribe button. See you next time.